No, not gonna start with okay. So my disk was full, so I had to stop at that point. I moved some stuff to some other disk and now I got space for recording again. The last video was 11 gigabytes of size, so I really need some video program to fix that. Where did I stop? I stopped with checking how to actually handle the Fibonacci overflow, like to stop and properly stop the program. There's a little trick we can use. That is, we know when it will overflow. What we're gonna do is we're gonna check when that's the case. What we're gonna do in the first line, we save 0. Here we save 1, and then we do the first addition. 1 has been saved, 1 is the result of the first addition. Second addition, first addition, 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 second addition, first addition. We know that it will overflow in line 2, the second instruction, which will have this one will have the overflow. And we also know that it will not be 0. I had the fear that if we just use this condition here, it may have, for example, in some case it may be that we get this result, which is not the case when we're doing Fibonacci and we only have 8-bit. That's not the case, so we can totally use this as a board condition. What should we do when we reached a board? My suggestion would be to jump to one of the last lines, so that we got a little bit of time it takes until it starts all over again. So that would be like, for example, 10 or 13. So that will be something like this. That's actually, or even go there, and then we got still 1, 2, 3 or so instructions before it starts over again. So we got a bit of time, which is not really needed, but yeah. This stays as is, because there will never be an overflow at this position in this edition, so we can just jump back to this instruction. This is really small code, and this should loop forever. So let's just kick it on and hope that this will have an overflow. So this jumped back here. This gives it a bit of time where you won't have any value on the display, and then we go to the first one, which is also 0, and the next one has that 1 there. This should actually loop until we get some form of overflow at that point. So it will do the same stuff as before, line 4, line 3, line 4, line 3, and so on. It will always jump back, and when this one has an overflow, which is this result, it's gonna jump to the end of the ROM and spend some time, and then gonna start all over again. You're gonna confirm that we want to see the 1, 2, 3 after it flowed over. That was now the case. Now it's flowing over. It should jump. Yeah, it's jumping out of the first 4 instructions. It's doing nothing, and then it's gonna go to the first instruction, then it's gonna save 1, and so on. Perfect. So it's perfectly working. Means, yeah, we got Fibonacci working. That was just for testing if the CPU works at all, and it's working perfectly. Apparently we did not test subtraction. We need to test subtraction at some point, but let's do it when the time comes. Point is, we need to connect this fellow with this display somehow. Nobody knows how now, how currently. First of all, we should get that display over to oh, come on, there we go, 100 block radius. Okay, yeah. Cat, there we go. I'm gonna put this somewhere over here. That's totally fine. Like so. I'm gonna just paste here, -A, there we go. And now we just need to connect that stuff up. Remember from first part, we haven't fixed the first pixel issue. Well, let's just accept that fact and ignore it. Not really that relevant. We'll just have to keep it in mind, or maybe remove the lamps, I don't know. Point is, yeah, what we're gonna do is we're gonna use two registers in here, which is for X and Y. And yeah, right. So that's basically the point. What we're gonna do, we have two registers which will be saved by this and the save line. I can actually put the registers here quite nicely, and then we have the reset line, which is one of them. One of the ones over here, which gonna reset, and one which actually will cause the pixel to be print on top of the onto this. And that can be any of these, and that will be a bit delayed, so that when we save and coordinate at the same time, it has some time until it reaches here before we're gonna flash it onto the display. If we have something like flashing, that also means that we need some blocking, and then we don't even have to worry about that extra pixel anymore, because if we have like this blocking, nothing can happen anymore. But that blocking will be enabled by one of these fellows over here, the same way as this one. Yeah, so that's basically it. Actually, the blocking will, the saving of the pixel will actually be enabled by the timeline, by the clock also. But what am I saying? We should just get this thing starting. We need two registers somewhere over here, because they shouldn't be that far from this wire, so that it's nice to have that stuff here in control and next to it. So I will use a 3 wide memory, because that's the most easiest to use with piston blocking. Orange. There we go. Fibonacci is working, that's good, so we can probably without any issues just connect stuff easily with each other. We need something like this. Okay, like this. Then a bit of this and a bit of this. Good. Next thing we do is I'll put some repeaters there for the repeater blocking. Oops. Oopsie doopsie, doopsie oopsie, oopsie doopsie. There's no much need for more sync and things like that. It's just a bit of time in which we have to dampen to this machine. There we go. Okay, there we go. Yay. So yeah, okay, that will be one of them. So at this point I'm just gonna remove this block and cell build stack up. There we go. These two orange lines just gonna go to this one here. I should use something like, well, I have this block and this block for the two colors. Let one be one color and the other one, whatever. Anyway, I'm gonna undo. No, I will not. I will just make this a little bit sloppy, like just gonna put wires there in some manner. It's not really important. It just needs to be connected in some way. Yeah, that's kind of an issue. Okay, I don't approve. But yeah, okay, there's a simple fix for that. That is to just make this. Damn it. There we go. So let's just put all the stuff here and connect that. It won't be like this. I'm still missing the clock line. This is just an enable line, so yeah. We need some repeaters, and this actually should be over here, because else we got a problem. And the other color is this one. It's gonna be here. I'll just put it on top, and then we don't have a space problem. There we go. As nice as this. There we go. Need some energy. Boom, boom, boom. So this goes up to this point, and this up to this point. We want more. We need more. Basically, this will be inverted at some point, like here, for example. Or rather, let's invert it over here at this point, because then it's much easier to place the clock line. Both lines need some clocking, and that is this color. So what I'm gonna do is I simply put like these here quite next to each other. Like this, and then I can just put like, I knew it. Okay, there we go. Just need to put that here, and then we can connect. Obviously that lacks a piston. We need a 2-tick signal, if I am correct, to power these, but it can actually be much longer. Problem here is that wire, so I'm just gonna connect it like this. Obviously we have to check if that's reaching. So normal, classic, as if it would work in the first attempt. It never does. Why actually? This is super annoying, you know? I mean, it's just one. Okay. Handle it. There we go. This is stupid. Because I failed. As one obviously can see, these should be blocked all the time. Oh yeah. Yeah. Okay. So what we're gonna do is I'm gonna put this wire somewhere here, and this one somewhere here. What this is gonna do, it's gonna send a signal to here. Next step relevant is that we need a comparator, which will be our gate. I'm just gonna put it like this. So the next step here is to just put a torch here. Oh, that doesn't work because of reasons. Well, for all reasons, there's the fix. There we go. So this is just on all the time, unless this one gives a pulse. And that actually helps us to like set some data onto this, like so. Saved and unsaved. The same should happen here. We're gonna just put it like this, and have like a torch here. So both should be able to save now, but since we don't want it to always save, we're gonna put some repeaters here, not there, here, for reasons. And now, as you can see, it's not saving when this is on, which is actually not what we wanted to have. What we're gonna do is just exchange this with the torch, and then it works just fine. Because now it's not blocking, and when the signal is off, it's blocking and it's not saving. So this is perfectly doing what we need, and it's here out of the way, and it just goes there, and that's good. So that part is done. The saving of the two registers for X and Y position. So the next thing is, what has to be done is to actually connect these wires with each other. That's a problem. We need to power these both, and we don't have much space for that. In the worst case, I have to move this a little bit over. Yeah, for that I'm just gonna use slabs. But this is kind of an issue, like I can wire this up like so, and that one needs a slab. Well, it's certainly possible, that won't be much of an issue. Yep, signal reaches here, perfect. Next one, that one will be traveling on top of this, and then go here like this. We're gonna get a little bit more path, but it's still reaching. But the other ones may be an issue. Oh hey, here we go. That was that one, and the next one, maybe the second one. There we go, it's powered, perfect. So the next steps is actually to go here. As you can see, there's a small issue with getting a signal here, and that is that we need to block here. To get the signal here, like this. Hours later, it's the reset. Yeah, there's still the problem with the last one. That one is the most tricky in this case. This is actually not so nice. Here we go, 5. And it still reaches, but the last one may not reach. But what we can do here is we can just use the upper one. Like this. This may not reach, and it doesn't reach. So I'm just gonna put a repeater there. It doesn't really matter about syncing because, well, the tick here comes much later. Is in value changes, tick, value changes, tick, value changes, tick, value changes, tick. So that's a lot of difference in time there. And with that, we have the two positions saved. Since I don't know yet which of these is X and Y, it doesn't really matter. But we should exchange the colors of this to keep track about that. maybe make this one in that color, who knows. Oh, it's not really relevant. There we go. Too few sport. Not enough. Okay. Next we need a reset line, and I'm just gonna use red because red and reset, that's kind of tasty. So this may shall be the reset. Oh, actually, let's put the reset here, and because it's closer to that line there. I'll just wire this up. This is like really just this part, which just connects to there, and that's the whole deal. So when this is on, it's gonna give a reset. Will be a long reset, but that doesn't matter. It just has to reset in some way, which, oh, who cares? So, boom. Got the outputs. Outputs have to be connected to this, somehow, and we have a flash. Which color to use for flash? Green? Well, that's possible. Haven't had green in a while. I think they use that color, so it's fine. Just need to fix the color of these. Get rid of that. And place some barriers in between. Why am I actually not able to destroy them? I am, okay. Just some weird timeout there. Okay, so there we go. I should take this and just stack it 15 times. There we go. So yeah, under this we need repeaters. Good that I have them. Brought them along because we need them. There we go. So ROM is extended. ROM is attached. Just need to connect the wires, right? So let's make, oh, this one's already gray, so it's gonna be the one going to here. Oh, this is actually annoying. Well then, I'm just gonna do it like this. Wait, what? Oh. Okay, okay. Now I just need to rotate this, like so, and go all the way down until we reach that level. Too deep. It's gonna be like here, and gonna need some of these. Not there, not there, not there. But here. No, that one. Yep, like this. So what I can do is I just make a nice corner into this, and do the same for all of them. Yay! Much nice tension. It's awesome placing wires. Watching someone placing wires, I mean, must be the most awesome stuff to do. And not that much of an entertainer to actually perform placing wires and entertaining. Oh no, I failed. I can't even place wires. Where's there no plugin for it? Why can't someone develop a machine which does redstone for you, and you just tell it what to do? Then you say compress this and it compresses it. That would be the total extinction of humankind if a machine is able to optimize. Whoopsie doopsie. Okay, attached. Now it's time to get some values onto this, like so. To place the what is it called? Well, the repeaters. My brain is sleeping again. Great. Perfect, dude. Perfect, you're doing great. Just sleep while I need you. Stupid brain. Darn. It's not reaching up to the top. Well, this is unfortunate. Oh, we're just gonna put it in a random manner. Oopsie doopsie. Should put it a bit like this. Just because it looks nicer. No other purpose. Okay. Oh, then we get them. The question is, how far does this one travel? Only up to this point. That means I'm gonna put all the other torches here. And I'm gonna put some of these on top. There we go. So when placing these again, layer 15 should be enabled. That's the case. Great. Another reason why you don't want to put unsynced data onto this line, and that's why we have the enable thing, so that it syncs it and blacks out all unused ones. Okay, next one. Perfect. So just undo this. Wait, what? I don't want to write some weird stuff. Oh well, I will have to accept this. By the way, I got asked earlier where the reset, or if this has a reset in general. No, this doesn't. It's not like real life computer have a reset too. When they boot up, they have random values in their registers, they have random values in the RAM, they have random values everywhere. So what they need to do when the CPU starts is to reset automatically. And that mostly is done by the code. So when you have this code here, you can see I'm using just register 1 and 2. And what I'm doing first is I set 0 into the first register. So you may say that's unnecessary because you could reset the whole CPU and then zeros everywhere. But I cannot expect that a CPU which is in a random state and got shut down has a 0 in the first register because it got reset at some point. So that's why whenever I'm gonna jump to this program at the first line, it will correct whatever value has to be in the registers. Even if it's zeros, it will write zeros into each of the register where it needs a 0 or any other value. This is important. You should always do that when you write code. You should initialize your registers with whatever value you need, because you cannot be sure that it's the correct value. And also cannot expect that this one actually stores the correct value. It totally can be random stuff like 1 in this case. And we don't want to write 1 to this display or something. Also, it's the same with this display. Like if you start the program for line drawing, you will want to reset the screen first, and that's something you do by code in general. So you do the line drawing, and when you start the line drawing thing, you say, okay, I want to draw a line, I'm gonna clean the screen. So that's what you do first. And then it doesn't matter what the state of the CPU is, it doesn't matter if you have no reset, you just do it yourself. And it's totally fine because it's not much effort. It's like one more instruction here, yay. And that's one which only gets executed once, so that's no effort at all. And in general, so that's why I say if someone builds a CPU in Minecraft, he should like not rely on something like a reset. There's like no real purpose for reset actually, in my opinion. Yeah. OMG. Putting wires while you have worded it, that's kind of poor. Well, line drawing, right? I mean, like one could just go here and say, okay, I have 2 blocks, and I say I place 1 block, and then I go here and place the second block, and it draws a line. However it would do that, it doesn't really matter. But that way one could just do, at least for straight lines, that's a perfect way of actually putting wires. Okay. Could just use stack. Could. Would reduce a lot of wasted time. Oh well. Nobody cares. Oh, actually, the wizard, whoever watches this, if someone watches the whole thing, I mean, like it's just a CPU of lowest grade. For people who probably know how to build CPUs, that is not the most informative video, especially since I derped a bit. And yeah, just need to connect this now. There we go. Bum 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 bum. Bum 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 bum. But if someone is kind of unclear or kind of has no clue how to actually do a project like this, I mean, like it's simply this. I mean, everybody could basically copy this, but it's nicer you develop your CPU yourself. And my first one was also that type, but looked entirely different. I mean, the base is always the same. You have a register file, you have decoders, and an ALU, and that's basically the core of it. But everything else can be kind of different aligned. Even you can even align the that stuff differently. I mean, most beginner CPUs, you can see in learning area, they don't have that design for reasons which I'm unsure of. They probably just use a different register file if they're using register file at all. Sometimes they don't. They just use some bunch of register and RAM. Totally fine. And if you go for a design yourself, you should choose whatever you like best. In my case, I consider this a really nice way of doing CPUs because I have plenty of registers with that, and I like to have a bunch of registers to play with them. And as you can see, or as I said in previous video part, that you need 6 registers for line drawing, at least from that code which I found on Wikipedia. I hate that. Well, the most important is the outerst line. Most outer line. I'm just gonna set this up here so we got the same length. And that fits until here and perfectly, so that should set the 50 by 15 pixel, which is the one on top. It does not, so something went wrong. This is off. This is not off anymore. Ah, right, okay, so it placed. Wait, this is not 1? Oh no. Wait, no. Wait, 1 is on this side, but on the 9 it's on that side. Oof. So there's a simple fix for that. At least. That is, one takes all the stuff, which is kind of a problem. This cut goes on the other side, flips it over, and just pastes it again. There we go. Flipped it. So now it should be this line. The 1. Ouch. Let's just trigger the reset manually and then yeah, just need to like trigger this here. There we go. That did not work. Alright, obviously it did not work. There we go. So now the bottom 2 pixels are activated. Now we only need the last part, and that's the green line. Green line gonna be somewhere here, because of convenience. What this basically does is like every pixel gonna be disabled like this, every line. And what we need to have when doing that is redstone, right? Something like this, and clean inventory. Someone said this is my, you know what? Oh, right, that thing. Okay, there we go. His plot is like very laggy. So what's needed to what has to be done next is just wire this up to the top. And I mean, I could do this non-manually, but it's so much fun to do it with this. It's so easy and so quick until you're at the top. Not okay, actually it is, but I'm not gonna do that for these here. Great job. What is it? Stack 15. There we go. Okay, the point is I need to power all of these in case that I want to save. I do that with this thing called piston, not that one, the other one. The problem is that I have to use the timing one, because if I'm flushing 2 times in a row, like 2 instructions after another, then this signal will stay on, it will not turn off. So I need to use the time signal to cut it off forcefully at the end of an instruction. What was that lag? Can someone turn this off, please? So for starters, I'm gonna put a redstone block there. To do the SS. How does it work? Something like this. And the same here. There we go. So that will be the safe mode when it actually writes stuff to it. Not gonna happen right now. Actually, I don't need this here because I can use the timing unit for that. Somehow, I'm gonna put that somewhere here. That means I have to get this signal over to the other side. Gonna go below, gonna go above. No, going to. I will travel. I will put it above. That's the point. I need to somehow get this stuff working. That's no good idea. Let's put it like this. So what we got here is kind of a knot, okay? But I can like put comparator here, which is oriented like this, actually here, and I will put a torch attached to this line. Basically, this means that this is constantly disabled, nothing is passing through. Unless for that moment where it goes on. Yeah, so if this is on, like if we have a signal here, this one will, just like here, pass it through. That's the point where we also should put a piston to cut down the signal. So just rely on this having a signal. No, JK, I need to put like this. There we go. Whoops, where am I? There am I. So, something like this. This won't be enough. Let's just hope it reaches. Obviously 1 tick is not enough. So let's just make it 3 ticks. That's plenty of room. And that's all torches, right? Great. Okay, all torches get triggered. That's exactly what we want. With the only downside that it's not delayed enough. So this actually has to be delayed by quite a bit to be sure that this is like really behind the setting of this stuff, considering that this will be saved at the same time. We got 1, 2, 3, 4, 5, 6, 7 ticks till it gets in there, and that's the time this has to take. And now we're clearly above because we got about 12, so that should work. Using the word should is like not recommended when you actually want to do something properly. They're talking about my stuff, but which design? Okay, and where's the other one? I don't know. Well, right back. Okay, so this has been added too, so actually we got everything we need for this to work. Time to flash the ROM. Why is there no tab completion in that plugin? Good. This is the point where stuff gets serious. Alright, that is getting rid of this, and that is what we need. So here's a binary. I'm going to put that over there. Okay, there we go. So the goal, first of all, I have to turn this off. This is kind of annoying. Shut up. First of all, I'm gonna reset the ROM. Okay. First of all, I said we have to insert values like x0, x1, and whatever. We're gonna reserve these, and I'm gonna put that down. Maybe we should put like a legend or legenda, whatever. I don't know the word. Let's put one more here. I'll just make it registers 0. Oh, there's no 0. 1, 2, 3, 4, 5. I say we need 5, so 6. So let's have a look. First one gonna be x0. Second one gonna be x1. Third one gonna be dx. Fourth one gonna be I should say it should be y0, and then we have y1, and then this one gonna be d, the magic value. With this in mind, we can actually start right into this. So cold. Good. So we need two numbers which gonna be drawn on that. Personally, I would say we're gonna use the. Oh wait, you know, there's this cool thing called banana. Where you just go and mark every other with like a block, which helps to know where to put stuff on, or actually to read it, which is quite helpful, and we need it. And yeah, I'm gonna add that the long way. Let's just hope that the code will be working. So I think the start should be this pixel, and the end should be, let's say, this pixel. So which pixels are these? This is 0, 1, 1 dash 2, 2. Oh gosh, this, whoa, no, falling. 15, 14, 13 dash this is 0, like 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the target. I'm gonna put them right into this right now. So the LSB of this here is on the right side. So I'm just gonna put these numbers directly into the immediates because right side. So the first one is X. So this will be something like that. Then we got 2, which is the Y coordinate. Oh, Y coordinate should be there. And then we got the other X, and that's 13. So 13 is 8 plus 4 plus 0 plus 1. And the other one is 8. So that's gonna be like this. Okay, that's the starting values. Now, time to save them. How to save them? No, where to save them. The 1 is X0. That's gonna be saved in the first one. LSB is on that side, right? LSB goes there. Yeah. Right. Yeah, indeed. Can you not? That is the Y0. That is at the 4th address, so they're going to be here. That is the X2. X1. X1 gonna be in the 2 number. And that is 8, which is epsilon. Y1. I should stop saying the German word for Y, which is epsilon. And I'm trying to make it epsilon. That's stupid epsilon or something with E. Anyway, this is the 8, which is Y1, and Y1 is 5. So in 5 is 101. Okay, that's how we insert all our values into the program. That will be just this. Nice. Time to do subtraction. The first thing we do is either this one or this one. I would say we do dx first. Dx has its own place in memory, and that is this one. What we do to get that is we take x0, no, we take x1, x1 is stored in 2, so that's 1 0, and subtract I should not do this. We take that one and subtract 2, so we take x0 and subtract x1 from it. If we want to subtract x0 is 1. 1 is the negative one, so we're gonna make that one negative, and we add carry in, so that subtraction is active. So that's just doing subtraction. That one minus that one. That should result in something which is wait, let me see, we had 1 and 13, so x1, which is that one, minus x0, and that is 12. So that should be 12. 13 1. Epsilon 1 is epsilon 0 is actually, what was that? It was 2, and that one is 8. There we go. So that's how it starts. So in this step we just did nothing else than calculate the dx. We're gonna need it in the next operation. So the next thing we do is dy. dy is a little bit of a special one because I said dy will be stored in the 4th position 2, and that is because we nowhere need epsilon y. Oh, we do here in that position. We only need that here, and after that we can use it as dy. So that's the 5th one. Dy equals well, that is actually epsilon y, which is epsilon is 8 minus epsilon 0, and epsilon 0 is 2, which is 6. And this is also an address 5. Means we're gonna go here and say 101. We're gonna go here and say 101. But we're gonna subtract epsilon 0. And epsilon 0 is 4. So we're gonna subtract that from it. Again, it's subtraction, so we need to enable these two control bits, not b and +1, and then we get 6 in dy. As we already know, we need only 2 times dy forever. So what we're gonna do is we say 5 is 2 times dy equals 12, or let's say 6 by 2 by 6, that is 12. So what we're gonna do, this is a simple addition. We're just gonna say, we're gonna save into 101, we're gonna insert 101, and we're gonna insert 101. This does, it takes 101, 101, so that is 6, and adds them together, which equals to 12, which is 2 times 6, and stores that again in 101. Yay. Okay, that is kind of simple. We're getting and this is just the setup, but there's just one thing left, that is d. That is 6. 6 is that value, and we're having a subtraction again, so we're gonna make b the one which subtracts from a again. A is the base number, which is dy, which is the 101 which we just defined, and what we're gonna subtract from it, that is dx. dx is stored in 3. There we go. So that will be where d is created. Yep. So d is also set up, that is 2 times dy minus, oh, just put the values there, 12 minus, and the other one was dx, and that is, wait, what? Oh, dx and dy are the same? Crazy. Which points did I choose? What's the difference between these? 1 to 13, wait, 1 to 13 and 12 to, oh, 2 to 8. Okay, that is interesting. Yeah, that's indeed this effect. So this one is by accident 0. Well, fine. I don't mind. Okay, and that's the point where the loop starts. Crazy, crazy, crazy. Okay. We got a loop iterator, that's that one. That stays the same, it's just a different notation. So that is actually the first address. What we're gonna do is at this point we should start. Do we even want to loop? Or do we just say at the end of the loop we check, do we want to do the loop again? How do we check that? That is by doing a simple subtraction. And that subtraction looks like following. We take x and subtract x1 from it, or the other way around. Doesn't really matter because what we check is equality. We check if the result is 0. Because if that is the case, we have reached the final and jump off. Okay, since I already said that, because we're using this kind of way, we put it right here as next operation. Oh no, we don't. Because if we do that, we will skip if we have the same, if we just have one single point, we would skip that. And that's bad. What we do first is we actually gonna reset the display. Okay, this is a bit of tricky now, because the program accepts, like torture, expects that there is always a bit if it places that down here. But there are no lines here, so this is kind of a problem. But as we can see, we got 1, 2, 3, 4 spaces. That means what we're gonna do is we just put 4 times nothing here, and then we continue. And sadly we have to do that for each and every row. Okay, first of all, we got the bright one, that is y. Then we have x, oops, yx, and then is safe, and then is reset. So that's the other ones. I'm just gonna put that in each and every row now. Okay. There we go. And this all without having placed a single torch. Really, you don't want to place torches. It's ridiculous. So what we're gonna do is we reset first and start, and that's all we do. So when it starts, it's gonna reset, and that's it. But what we do here is we need to actually save the values somewhere. And that is what we do at first already. Because we want to, it's the first instruction which we execute. So what we do is we save the x and the y to it already. So we need the x0 is the first x1. That is 1. Save the 1, so here, so that will be saving the first x. And the first y is 2. We're gonna we're actually putting 2 in here, so that is the first y. There we go. So this already saves the first step, and what we do here is we just print that one. So at this point, this instruction, we're just gonna print whatever is in our cache. Once done, we continue. What we do when we continue, we check if d is bigger than 0. How do we do that? We take a and b and check if a and b is bigger than 0. And that happens if we do this. We're doing a simple subtraction. We're saving nowhere. And we're gonna take d as a and subtract 0 from it. That happens when we just put D in here. That's all. And all we have to do now is we check if it's bigger than. 1 here is bigger than, so A is bigger B. That is here the case. And if that is the case, actually we want to check if that's not the case. How do we do that? Oh, it's quite easy. We just go 1, 0, 1. Because if it's equal, or if it's smaller than, then it's not bigger. Perfect. So if we do that, like if we have this case, we want to jump here. Oh no, new line. Jump here. Okay, like that. But else, okay, so we're not gonna jump here. We're gonna jump here. Why is that like failing? Good. But what we're gonna do here, so this is the check. So now we need to increment y. Y is stored in here in the 4. That's just y, which is 2. So oopsie doopsie. Y is in 4, so that just means we take 4 and take 4 and add 1. So that's incrementation. Voila. What we also do is we store this result in epsilon here. Else we don't change epsilon, the value doesn't change in the epsilon register. It's still that one, except we increment, then we override it. Perfect, isn't that great? That's all we need to change epsilon, like just that one and the one here. No, that there, it's actually there. We haven't written that as a sampler, so no need to actually do that. Next instruction, we take D and subtract from it. So let's enable subtraction. There we go. And subtract from D. D is 6. So let's take that one, and A we make B the negative one again. And what we're going to subtract from it, 2 times dx. 2 times dx is stored in nowhere. Oh, that's not good. It's totally not good. This actually will be stored in 3, but it's currently not stored anywhere. So we're gonna take one of the last ones here and go here. So maybe I should have started to comment this stuff here. So comment to actually know what I'm doing here, because you easily get confused and you can't even really comment that down there. So y0 equals 1. Oh, that's actually x. Oh, by the way, I'm used to that symbol as commenting. That is 2, and 2 is x1. x1 equals 13. Mind that I am not using 1 and 0, else the compressor won't be able to read it because it doesn't know commands. It just skips everything which is not 0 or 1. But that means you, outside of these that field here, you're not allowed to use any of the bits 1 and 0. So, and that is x1 equals 13. Huh? What have I failed here? This one is 2. And it's actually 2, register 2, which is x1. Are you sure? Oh wait, this one is... Oh, this is 4. Okay, this is y0. Good. Oh, I was so confused because I didn't recall that. So this should be y1. y1 is stored in 101, and 101 is 5, and 5 is y1, and that will be 8. okay, at this point we have 3, which is dx, and that equals 12, or let's just make it properly, that is 2 minus register 2 minus register wait, which line are we? 1 is nothing. Okay, there we go. How to continue? What we do next is we save into 5. 5 is our y1, so we override that with dy equals, so this, I should actually change it with the whatever value that is. So register 1 currently contains the x1, and this is obviously then the x0. By the way, you should get a nice font where you can see that 0 has a dot in the middle and O doesn't. Like, so that's the difference between these. Else it may be different if there's just a small width change or something. In the best case they have the same width, then you just have a dot in the middle or something. This font is called Hack, by the way. And it's monospaced, so you can easily make rows no matter how big or small one character is. It's quite nice. So monospaced for your text editor, perfect. This is text editor sublime text. Cost money if you save too often, it gives a pop-up, else if you're not paying for it, but else you get the full functionality. Okay, there we go. We're at 5, and that is dy. dy is calculated by epsilon y, y1. It's y1 minus y0. Just confirming that it's really y0. We got y1, which is 5, and we got y0, which is 4. Correct. Perfect. So now should be the point where we multiply that. Okay, 2. Right. 2 times dy equals, and this is quite straightforward. It's dy plus dy. I use straightforward again. Okay, this is the point where we have that one. That is 6. Where's d? D is equals, this is subtraction again, and we do 2 times dy. I should remove this 2 dy because that's how notation says it has to be. Minus 3, which is dx, and that's the point where we forgot the step where I added this one, because at this point we want to multiply dx by 2, and that means what we do here is we take dx, that is this one, and just add it to itself like this, and this is just 2dx equals dx plus dx. As easy as that. And now we're at a point where we can do this instruction, because now we have 2 times dx, which is here, that one, so we can do the subtraction properly. So I'm just gonna put the comments here what we're doing here, because it's not quite obvious. Plot point. In this case we got compare, this is d bigger 0, and what we do is we don't jump, so I'm gonna put a label, jump label. This is just a note so that we know. Else we jump to jump label, else to jump label, that's that. Skip ink, or just call it skip ink, and I make a lowercase though that we know it's a name on its own, and else skip ink. We jump to there if we're not doing whatever we do properly, so we need to change the address here at that point. Next one. This is increment. Increment, which are we incrementing? That is 4 is y. So just say y or y0. It doesn't really matter. It's the same thing. I just name it y0 here. When we do that, we're also storing it. Y is the register of this here, or at least I declared as that. And what we do then is we use d and subtract 1 that. So that is d equals d minus 2dx. So that is what we do here. Let's confirm. 3 is dx, or exactly 2dx. Yeah, no need to wait. I can actually, for debugging, I should write that down. 2dx in this case is 24. So what we're doing here is we're subtracting 24 from d, because d was over 0. So we got a negative number. That's why I said we need more than 4-bit, because else this is kind of tricky. Jump here. I already made the label here. So what we're going to do if we're not doing this, like if we're skipping this, or what do we do anyway? We take this line, just put it here again. That is d equals d plus 2dy. 2dy is stored in 5. So what we're gonna do is we're gonna put 5 here, and we're not doing subtraction, we're gonna do addition. So this is addition. That is d. So d plus 5 stored. Done. Next step. This is the point where it gets critical, because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 instructions in total. Great. So we just have 2 more instructions to get the loop done. Sick. Yeah. I should put the skip hint instruction. So where was I? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what we need to put here is 13. Put here is 13. The LSB is on the left side. So we need 1, 0, 1, 1. That's 13. 4 plus 8 plus 1. Does that match? The LSB is on this side, so it goes to that. Yep, perfect. Not gonna mess this up. I mean, it doesn't really matter if we mess these up, because they are just mirrored if we do it consistently. But here it's critical, because that tells where to jump here. Also, if we mess that stuff up and all the bits, that's not cool. Also that's not cool. But this one's the most critical, and these actually. Oh, funny, it's 13 and 13. I knew I did 13 again already. Did 13 already today. Good. That is that instruction. So here we go. Last instruction. If we do x incrementation is bigger than, is smaller than, smaller equal than x1. What? No. What we're gonna do here is we're gonna take x, or let's just call it x0 equals x0 plus 1. So this is simple incrementation. Means we set that. We're gonna have the x0. x0 is in 1. Save that, put it here. So this is just a simple incrementation, and what we do is we also save that to the register. SS8, don't place the bits wrongly. It's already difficult enough to place torches, but this is already easier with the bits in the text file, really. And by the way, feature only on this server. But yeah, and yet it's not public available, but some players are selected to use it. You can always ask me and I will give you that feature instantly. Like, there's no big deal about that. Because it uses the world edit selection, you get the permission. But if you cannot make the world edit selection, you don't have permission to use torture for that area. It's as easy as that. And world edit selections are protected on our server. So this is just an implementation, so we got the next why. So now is the point where it really gets critical, the last instruction. Okay. Subtraction. And what we subtract here is we subtract either of the two, x0 minus x1 or x1 minus x0. It doesn't matter, because we're checking for 0. Because if it's 0, we're not gonna jam. If we do that, it won't save. Oh, that's bad. So yeah. If that's the case, damn, assembling machine code is so nice. If you got limited space, I mean, like, I could extend the ROM, but that's for noobs. So let's just don't care for the last point. I mean, everyone is able to just interpolate another point. We got to get this working, and in the best case without errors. So yeah, what we actually need is if this is not 0. If this is not 0, it's a bit of tricky. Oh wait, it's not tricky, it's easy at all. Easy in general. So we're just gonna put x1, that is, I don't want to save that. So 1 0, and that is x1 is, oh, x is 1, that, obviously, okay. So we're gonna do a subtraction of either direction, and what we're gonna do is we say if it's bigger or smaller, we're gonna jump. Where we're gonna jump? To loop start. I'll just name it loop by now. If is like x0 is not equal to x1, then jump there, jump loop. Jump loop, and jump loop is there, so we need to do beta counting. 1 2 3 4 wait, 0 1 2 3 4 5 6 7 8 9. We'll jump to 9, 10 11 12 13. Okay, that was correct. And I'll jump to 9, and 9 is like the really nice number. That's just this number. It's jumping to here. In my opinion, this could be merged with the next line. It totally can be merged. Why is that different? Like, we still have one left, so I can just go here and put that behind and make more room. Similar this and like this. There we go. Plot point. We put the point plotting one there. Make that a 0 and move it. But if we move it, that's the problem with absolute gems. Actually, we can also plot the point here, it doesn't matter. If we move it, we have the problem that we have to recalculate these. 0, 1, or I can just use that one and subtract 1, 2, so we get 9, it's the same. This one is still 9, because it hasn't moved at all. And then we go this one, 15, and we subtract 2, which is 14 and 13, and we have to subtract that one. So 3, 15, 14, 13, 12. So 12 is what we need to put here now. I mean, it's logical, we move that up once. And that's it. Okay, we got it. Sample the machine code. Oh damn it! Oh really? It's on point. It's on point. main machine code, and flashing, clear then, and let's select the machine code and not the machine. Damn it. Okay, I just make it proper. Select the ROM, torture, write back app. Oh, why should I have to do this one? Okay, it's resetted. It's defined the new one, which has more bits. And now I just need to use the command. Oh, damn it. What a bunch of Unicode stuff. Pretty binary. No, damn it. It checks. It actually checks how to put, whether to put torches there. Damn it. Okay, now we got a problem. A big problem. Is not a redstone torch or air. Replacing could damage something. So that is right. It's my favorite block. It's right, that one. I'm gonna remove that. Isn't that like a force argument? Let's first reset this. Place again. Abort writing full. Okay, full is no problem. That's totally fine and expected. I'm flashing more bits than this can hold because numbers. So first of all, where do I have to fix this? I destroyed it. I have to fix it. Oh, this is a problem. Here. Okay, like this. And once over here. Perfect. So the bits are set. Do we want to control them? No, it's working. It's fine. I trust that plugin. I wrote it myself. Okay, that's no argument. We're somewhere in the middle, which is kind of bad. We actually want to be at the beginning. So let's hack this somewhere, somehow, do stuff. And this is all one. All one is okay, that means it's gonna plot points and, well, it's fine, I just turn it on. Okay, this is working now. So what it does is it reads the values into the machine, and this is the point where it generates dx and dy and multiplies one of them, and then it creates d, and then it multiplies the other one by 2, dx by 2, and now we got the condition, the loop. No, that actually point plotting. Whoop, that's the first one. And it skipped it because it's not gonna do that. So, oh, tension, and it's quit. Why? Why did it quit? What's with you? Damn you, potato. Okay, so what we're gonna do at this point is we're just gonna manually cycle the clock. Yay! I've never wanted to do anything else in my life. So we got a bunch of registers and need to read all the values. Like for starters, I can just do this, and then we're on the first instruction. So we have to check is value 1 arriving here? Value 1 is arriving here. Great. The next one is we have to check which is the one of the wherever it saves. It's saved to 0. That's the downside. I cannot see which one is selected while it's not saving. But it's actually saving to 0. So, that, my cheat sheet, put it there so I can quickly control tab that. So the first thing we do is we store x0 in, we store 1 into that. Perfect, should work. Clock it. Control, 1 is stored properly. Store 1, perfect. Next thing we do is we do epsilon 0 store 2 in there. It's 2, I can see it from here, like there's 2. And now we have 0, 1, 0, 1, 0, 1 is 2. And that is the initial value, and that is stored in 4. So this should be 2, and the one which should be activated by now is 4. This is 4, 4 is activated, cool, so I can save that. After saving, I really have to check every stupid cycle. I have to check if the 2 is stored and not 2. What was it? Was 2. If 2 is stored in value register 4, so here we go. That is this one. That's 4, so 4 is stored. So next step. Next step is 13. We're gonna store 13 into x1, and x1 is 2. x1 is 2, and it stores 13. So this is the value. 13 is that value, and we store that in register 2. Register 2 is enabled, cool, so we're gonna flash that. So we can probably say that and assume that this is working. The saving of the first values is working perfectly. There's a meme on the server which is called banana draw. The problem is we got a bunch of line drawers on the server which all drawed shapes which not had been lines. More like they had been bananas. So the challenge is to not make a banana, and this is my very first self-made this is my very first made line drawer, and if this messes up, OMG, I hope not. And with 2.5 ticks per loop, this is okay, but that's too slow for a line drawer. Hardware line drawers are faster. And when I stop, I think I stored 13 into here. And then we got the next instruction. That is actually 8, which is being stored in 8. Is going to be stored in which register? Apparently this... Which number is that? The 5th one. 1, 2, 3, 4, 5. It's the 5th one. Okay. So it's going to store in 5. 8 in 5. 5 is y1. Perfect. So I'm just gonna save that, and by now we got all the values, like all 4 points, loaded. And if we check this, the first point is x1 and y2. Perfect. So that works. So the saving into the x and y registers also works. What's the next step? We got 8. Did I save 8? Like, is it still the immediate 8? No, it's not. What is this now? So we're at a point where it's not the basic stuff. We're calculating dx. Oh, right. And dx, the first one is actually 12. It should be 12. B is inverted, incrementation, it's subtraction. Okay, it's subtraction, check. It should be x1, which is 13, and x1, which is 1. Are you sure, mate? This is x1, dx? Wait, dx is actually 3, so the third one should be enabled. Oh, I can just look at the binary. That's actually 3 apparently, and 3 is enabled. So this intends to store 8 into register 3, but it should store 12. Why isn't it? Is the input correct? We got 9. Why is this 9? I've got 1. Okay, again, why is this 9? I've got 1. 1 is correct. 9 is not. What should it be instead? 13. So this bit is missing. Why is that bit missing? Where is it even coming from? Can someone tell me? These here are off. So that bit is... Why is this one not saved? I'm very sure I confirmed that it properly saved 13. Maybe we got some really nasty bug in the memory. I hate these. It's the... Oh, once this memory works, it's perfect. But if it's not... Gosh. obviously everything else which happens behind this step is broken, because that is not set. Because this is not set. So what I'm gonna do is I'm gonna run it again, this time on clock, and then we're gonna see what actually happens with this, in particular just this register. So that's 13 stored in it, should work. And that's the point where it broke. You saw it? It just broke. I don't know why it broke. I'll have to just reset the CPU again and have a look at it again. It's awesome. Really. It's super awesome. Time to continue. So apparently there should be something like 13 stored in here. I should look at the save wire. So there's 13 here. And it changes by itself, without anything doing anything. That can be caused by that torch, by the way. Also, I'm unsure why that happens. I need to find something in that area which also reacts to then find the cause of that thing to happen. And it's not the first one. I had that with the first one, that's obvious. But it was that one. Is it just because of why? Are you kidding me? Since when is that? What was the issue in this one again? I forgot. No. Okay, it was the repeater on the wrong side. Let's try again. Oh, this is debugging. Okay. There we go. That's the piston in question. No, that is the piston in question. What? How? How the heck? Oh, come on. I'm almost recording for 2 hours already, so 1 hour and 40 minutes. That file gonna be huge. And I have to process all these files. Anyway, I got a bug here, and that bug has to be fixed. Should be stuck on the last line, which means it's gonna plot random points there. Well, okay. So apparently there's something which triggers that block too. What? How? Really, how? I have no clue. How's that working? Like, why is that happening? There's like nothing near me. Like, these are too far away, and that's not working, and this is too far away. The only thing which could do that would be this, and what? Why is that the case? That's not the case. That is not the case. That is not the case. What triggers that one? Am I stupid? Oh, I most certainly am, but why? I really don't get it. Like, why is that happening? We got someone who's clever online, or Jetfee maybe. Come on, save it. Am I looking at the wrong line? No, I'm not. Oh, now it's the second one. Okay, there we go. So it's saved, and something happens. Bam! It stopped for no reason. I have no clue why. Okay, that's actually never the cause. it's really weird. Sometimes other people can help you, like last time I also had issues with my other bud memory, and that was in the learning area, the one. Oh yeah. So no clue. I could actually look at that one, but it's different setup. So I'm not quite sure why this one fails. Like, bam, nothing, no wire, nothing. But it just retracted. I'm just gonna look at the learner one. Maybe I find the codes there. Cause, not codes. Oh damn! I lost my orientation. I didn't. Oh, there we go. So what have I done here? This is a total different design, but we got also 2 blocks in extended state, and this may be the issue, because that one goes up 2 blocks to trigger one of these. That is an issue. So what I actually need is 3 blocks difference between these ones. Let me guess, I don't have that again. Ba-ba-bam. Nice. I have to lift this whole thing up once. Nice. No. Ah, damn it. There are things in life which are probably much more fun than that. No, stop doing stuff. I'm busy. I'm still recording. Okay, so this is instantly writing to that, so it jumps to the last instruction. Means there's no data on here. Perfect. What I need to do is I need to reset all these. Else I cannot perform what I did on it. Okay, it's unset. Good. That means that this torch here, for example, triggered, for example, that piston or something like that. I don't know. It's logic. I mean, it's like redstone. I mean, redstone has no logic. It. Damn it. Okay. For safety, I'm also gonna move this at 1. The main problem is actually this one. The rest doesn't matter. Okay, I have to put this here. The problem is this still working? No. Why can't I go crazy? Okay. De facto, I don't have to lift the crown. The crown. I call this crown because it's the top. I have to lower that stuff. I can actually do that by just putting like these, like that. So that works. I can do that consistently. I have to lower that one same way. I have to put redstone on top. I can just lower that one, and I can just put that one there and that one. So that is no real deal. So something like this. So this is the new cell design. I'm just gonna take my wand and put that, like stack it 7 times, properly, unduly, and hope that V didn't destroy too much. because normally when you do that it destroys everything. It didn't. Cool. I don't know what that did, but it's good. It's real good. I'm just gonna put this here, like so. This time should work. There we go. So what I need to do next is I'm gonna take this one, that, and do the same in this direction with just 6 stacks. Bum bum. A lot of stuff happened. Undo. This is totally not intentional. Okay, there we go. Why didn't that fail just now? I saw an issue. Let's pray that this will solve the issue. There we go. So this kind of fixed the crown distance. It also made a new problem in this one. But I believe we can just do this and are happy. Cool. Okay, that's cool. There we go. So this might work. This may also fail. I'm unsure. Let's just pray it works. I'm just gonna start this again. It's on the last line, right? Right. Gonna start again. Oh. Is that an 8? Oh no, it's not working. It's not even drawing anymore. Oh, there it is. But that's the wrong X position. And it did not jump. So it's still broken for probably obvious reasons. I don't know. What's that numbers? I believe I totally up the memory. Oh. Wait. Okay, so something like this. Oh, look at that. There's an SS issue. Oh, that explains a lot. How to handle it? I could lower this. Actually, I'll do that. So, let's grab that one. Grab it here on 2 in that direction and just move it down. So, and then I'm just gonna remove these. It's also more safe in terms of how close the torches are to that. Where's that still working? Ah, yeah, right, it's working because of that. Oh, cool. So I just need to reset this thing. Let's have a look. Where is it even? Why didn't... Okay, my reset is stupid. It did not work. So, I just have to wait until it broke at this point. It did not. It looped. And it totally loops to the wrong position. Why is it doing that? Huh. Stop it. Go away. Loop once. There we go. So this is the first one. The first one should not save 0. The first one should do something else. The first one has 1 here. That 1 should go in here. It does. It goes here. It's there. And why is that 1 not passing through? Have we failed something here? 1 is there. 1 is there. So 1 is off and both are on. Why is that on here? Is it on by default for jokes? Oh. Oh, okay. Yeah, I get it. Okay, so for those who have seen this in the video before, just classify me as noob and you're fine. Yes. You know, it's not done here. I didn't do it here. I never tested. Oh wait, I did use that one already somewhere. But I don't quite see how that one is different from the other one. Like it's perfect actually. So there's like no big issue with this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Probably have to undo a bit. But if that one really was broken like this, then the one on top is also broken. But I'm unsure about that. I wonder where I can look at a working one. He has CPU somewhere on his plot. That one, oh, it's a vertical one. That doesn't help much. Maybe he has one. Hey ho. You're gonna load chunks or you're gonna... Don't. You're not. Here we go. Oh, okay, this is a... Well... wide design. Decoders are here, control. So this has width. It has more than 3 widths, so this is actually not helpful either. I saw some which are small. That one maybe. No, that's also 4. But it's smaller. But I need less width, more height. Why is there none like that? Where do I get one of these? Okay, so that's an issue. I know that there's not a learner area. I mean, I could look it up, but I'm unsure. I think I'm gonna quit the video now and find a solution for that issue. Search for a working one, and then I'm gonna fix that in the next video, or undo to get the other one working back. Because this one's already 2 hours and bug fixing is not as interesting. I just need to find the codes and not bother you with that. That may take a while. It's almost 8 past 18 o'clock, so you will know how long I took in the next episode.